So now, people, we are super, super happy and delighted to welcome to the stage a man who actually gave a backup talk on something else already because he's such a nice person and because he has talks that he can just do. He asked me to do this talk. I said no. So instead, have a warm round of applause for Theo.
All right. So my goal here today is to cause some trouble. I will highly encourage you to ask questions, probably stated in the form of "you're wrong and this is why." I am going to present the concept that doing a worse job makes you a better craftsman. So that's a little unconventional. Probably something that you would take issue with. And then at the end, I'll try to qualify it in some context. So the purpose of this talk is to talk about how performance and availability are measured and how you should be making promises to other people in your organization about the components that you build. So we take a quick tour through math, and then we're going to talk about how you can be fantastic at your craft by doing a crappy job. So quickly, I'm Theo Schlossnagle. I'm at Postweight on Twitter. I do a lot of stuff in the tech world. Serial entrepreneur. I founded a whole bunch of companies. I spend a lot of time with ACM. So if there are any ACM members in the crowd, feel free to chat me up about that. But here we go. So what is minimal viable product? I'm sure everybody has heard this term. This is basically how to build things lean. You basically want the smallest effort into a product to make it testable with an audience so that you understand that it fits. You don't want to invest a lot in making something that doesn't fit your audience because then that effort is wasted. So you want kind of the minimum product to get feedback in order to develop a better fitting product and take that one to market. So this is a really common thing. And remember that this is a product. How many people here work on a product? All right, yeah. How many people here are responsible for the product or a part of the product? Part of the product? A component. So this is focused mostly at people who work on parts of products, because that's what almost all of us do. So I like to think that I work on a product, and it turns out that I'm just a cog in a machine, and I work on a piece of a product. So what is minimum viable quality? So minimum viable quality, I just made up the term, so I get to define it, which is fantastic. Hey, you can't argue with this, because it's mine. The minimum performance and availability required of a component so that no connected components suffer incidental quality issues. This is the absolute bare minimum you can do and not break people who depend upon you. Right? That's simply what the minimum viable quality is. It doesn't necessarily need to be a number. It doesn't need to be fixed. It can change over time, but it is the bare minimum. So, like if you have children in school and they're trying to plan that worst possible grade where they still graduate, that's the minimum viable quality. Unfortunately, they are the product. That bad idea. They're not part of the product. So you don't want minimum viable quality for a product. You want to think about it in the sense of components. So we're going to take a quick detour into how one would even quantify these things. There's a lot of terms I'll probably throw around. SLI is a service level indicator. It's like a thing you're measuring. Service level objective, I think, is a key concept. That is sort of an objective quality measurement, usually around performance and availability, kind of separately. You'll have two SLOs, one around availability, one around performance, that is part of an agreement, service level agreement for your piece or your component or your product. So don't always think of these things as fixed thresholds. They are commonly thought of that way, which I think is sort of a broken concept. We're going to walk through what looking at the performance of a component looks like. So the craftsman's trap. A craftsman wants to build the best possible product. And I think that that's pretty fair. And when you look at a lot of history of craftsmanship, there were craftsmen that were really good at building one thing. Like somebody built hammers. They wanted to build the best possible hammer. And that's great, because there's a lot of people that use hammers. That's fair. They were building a product. But there was nobody building the best possible handle only, right? They were perhaps providing the best possible wood, but the handle was really part of the bigger product. So you were thinking about it in a cohesive sense. And what's really interesting and counterintuitive is that by looking at just your component and thinking of it as a product, by trying to build that thing as best as possible with the best performance you can do and the best availability you can do, you actually sabotage the larger product because you're building things that are unneeded. You're over-engineering. So how do you define objectives? We're going to go through an example of, say, a REST service. It's an API call. Let's say it's like putting an item in a shopping cart so that you can check out from a commerce application. You can make believe whatever it is. You're adding an event to a calendar as an API call, something like that. So typically, a naive engineer, or especially a naive product manager, will be like, oh, we have quality requirements for this. It should be fast. It's like, okay, that's a really shitty quantitative measurement, right? Like, it should be fast. Then they'll say, no, not it should be fast. All interactions with this component should be fast. And then, of course, someone says, the fast is not a number, let's have an objective here. And then they'll come back and say, okay, all the REST calls should succeed within 500 milliseconds. Okay, so this is an absolutely unrealistic expectation. First, you've decided that you have a 100% success rate. That's pretty nuts. And you also have every single request that ever happens in under 500 milliseconds. But what's really important here is that this is an unbounded criteria. So let's say just now you had your first request that was 550 milliseconds. Your service is never successful now, because all requests were not faster than 500 milliseconds. You can see how this is kind of stupid. And you would say, well, nobody really means all requests ever. Well, what do you mean, right? So you have to say what you mean here. There will always be outliers in data. This is like a simple latency graph demonstrated in a histogram. You can see most of the things are really fast. You actually have two modes in this. You got some fast stuff and you got some slightly slower stuff. But there's this long tail that goes off the end. There's always going to be slow stuff in your environment. So all queries should never be fast. Or it's never all queries. So how do we do this? Maybe we'd say 99% of our requests should succeed within 500 milliseconds. Right? So this is unbounded. Right? So if I have that one slow request, now I have to wait for 99 more of them to come around that are fast enough before I suddenly am back within my stated objectives, which is just really a strange way of looking at this problem. So what we need to do is we really need to define this with all sorts of auxiliary time constraints. So the first thing is to do a time quantile of assessment. Typically, you're not looking at all requests. You're looking at all requests over some period of time, some reasonable period of time. Most internet-related software companies that have customers, they try to look at this stuff in 5-minute chunks. And the reason that they look at 5-minute chunks is that most platforms end up having enough interactions in a 5-minute period that you actually have data to look at. And when you start looking at a day, there are 288 days, unless you live in a place that's horrible, like me, that has one day a year that has 23 hours and another day a year that has 25. They typically have 288, all 24-hour days. So you have these 288 units where you can say, I'm going to look at this 5 minutes, and when that 5 minutes is over, I can know whether I succeeded or not, right? 99th percentile, maybe just in those 5 minutes. So that's really, really a simple way to make a sort of complex math problem a lot more digestible. So maybe REST calls should succeed within 500 milliseconds in 99% of my 5-minute periods. So if I look at those 288 periods, 99% of them should have only rest calls that are successful and 500 milliseconds or faster. So the problem is this is unbounded for achievement, right? So you say, in this case, say you have a very bad, no good week, right? Where you blow it all week long, your service is completely out. The math on that doesn't work out very well in your favor. You have an entire week, if you're looking at 99% of 5-minute intervals over a relatively unbounded period of time, it's going to require 2 years in order to start to fall back into that idea. So can you imagine getting hired in March and saying, we're going to do awesome, and they're like, not this month, right? 11 months from now is when our time horizon comes in where we can hope to succeed again. Okay, that's one, bad for morale. Also, just a stupid sort of objective, right? So we have these 5-minute quantiles would make sense, but we also need this larger quantile of evaluation, right? To understand what time ranges do we consider that we should be successful over. So this is a little closer to what a lot of SLOs look like after you've iterated and realized you don't have enough data. So 99% of the REST calls in any 5-minute period should succeed in faster than half a second, and no more than 3 of these 5-minute periods should be violated in any month. So that's a pretty tight time frame. So every 5 minutes, you look at all your requests, make sure 99% of them are successful and fast enough, and then you say, yay, this 5 minutes was a win, and next 5 minutes hopefully was a win, because you only get 3 losses before that month is in the toilet. But luckily, next month, try again. This has some slight problems, again, that we'll get to in the next slide. But no, this slide. So one of the problems is months suck too. I mean, we're human beings. If we didn't kill ourselves through war, we'd kill ourselves through time zones and calendars. We're just horrible. So all months, basically, almost all months are different lengths, right? So can you imagine trying to do the math in some sort of rolling pattern where you're like, oh, we only have 3, and it's like, that's not fair. This month has 31 days, and last month only had 28. It was so much easier. Well, it turns out that's a kind of a huge problem in this, because people build these charts called burn down charts for service level objectives, where they'll set these performance requirements and they'll say, I can have this many fuck ups per month, and you're climbing towards this very bad, no good month. And what you're trying to do is regulate the velocity of your development. Right? Go fast actually does mean break things most of the time. So if you go fast and break things, that's fine as long as you're still within your objectives. But as you get closer and closer to your objectives, hopefully all the engineers and project management that would like to get their bonus that year, they say, hey, maybe we should just chill a little bit, be a little bit more careful, and not screw this month up. And then the next month it resets, and then you start kind of going crazy again, and you take more risks. The beauty of having those things numerically quantified is that you can quantify your risk levels. You can actually tell people, hey, fuck around and find out. It's great, right? We have budget. We're allowed to screw up. There's none of this, it always has to be successful, it always has to be fast junk. There are times where, you have a budget for messing up. That allows you to go faster, take more risks. You can test in production. You can do all sorts of stuff. It's great. So there's a more subtle problem with this that people run into, because all of these ideas really sound great. I actually do argue that these ideas are fantastic and they can be used to great ends for building software, especially as your teams get larger, more complicated, more components. You set all of these SLOs per component. You allow your teams to run amok or go very, very carefully, depending on how much budget they have left. But the problem is, the way I described that previous one, 99% of requests in 5-minute intervals over a 28-day period, talks about a service as if the service is one thing. And a lot of times, we have multiple workloads. in the service. So you have a service where some of the requests are slow, and you know some of the requests are fast. And you don't want to artificially set that thing up to 500 milliseconds, if you don't have to, maybe. But you also don't want to get penalized for things that you know are going to be slow. If you have certain workloads in there, for example, let's say you had coming up with it on the fly, but you have some sort of search product where you need to be able to identify certain items for putting in shopping cart. Like, hey, you like these shoes, you'd also like these other shoes, right? But there is one type of query there where you can say, show me all shoes that were ever purchased by anybody who's friends with me and friends of those friends, right? And it's a long list of stuff, and the query always takes about 2 or 3 seconds. It's rarely run, but people really want it. It's part of your service. So now you get punished anytime someone uses that query because it's actually, you know, that bare minimum of your ability to deliver that query is actually slower than your objective, right? So that's not a reason to change your objective as much as it is to change what your objective applies to. That's a different thing. So you should be very, very critical of how you write these SLOs. Because if you do this right, it gives your organization better velocity, but it also means that you are spending money in the organization, hire, fire decisions, all of that stuff based on these numbers. So they need to be incredibly articulate and purposeful. So now we come to the bigger problem. There's all problems all the way down. Why 99%? Everybody always says, oh, 99th percentile. Why is it 99? Why isn't it 99.3? Right? Why isn't it 42? It's the enter to life, universe, and everything. Why is it 500 milliseconds and not 480 or 200 or 280? Right? Why 5 minutes? Why 28 days? Why is 3 okay but not 4? Right? I don't have answers to these questions because these are a fictitious REST API providing services to other components that don't exist. In your architecture, you have components that are being used by other things to deliver an overall product. It takes a lot of intentional work to set these things correctly. So what I'm going to talk about is not how to set these things correctly, but where to aim, which is counterintuitive. So there was this year an exceptionally good talk at Usenix by Narayan Desai and Brent Bryan from Google. I have some bones to pick with him on terminology. Fantastic way that, so Google kind of came up with this whole SLO, SLI stuff as a part of their site reliability engineering initiatives. And this one is sort of dissecting it and saying SLOs don't really work. Do SLOs this way. So, but they use a different word. They do principal performance analytics and they do workload classifications and things like that. But at the end of the day, they're still describing an objective for a level of service. So it's absolutely an SLO. It's just not done in the traditional way of this sort of 99th percentile fixed limitations. They do a lot of efforts on workload classification. And what they're trying to say is that I don't really care, I mean, I care that it's slow or fast, sort of, but I really care about deviations in behavior. I care if it was slow and it became fast, or if it was fast and it became slow. Those are my indicators that I need to keep consistent. And it's really interesting work, so great presentation to read. So, minimum viable quality. This talk isn't really about SLOs. We're going to assume that you're all SLO experts now, and that you all have SLOs on all your components, and you have been chastised by your colleagues that your component isn't fast enough. It's not available enough. You didn't meet your promises. I'm here to tell you to promise less. It's important. So craftspeople in general tend to take the development of their software and their components very seriously. I hear people rant about how much they want to do their test-driven design, how they want their code to be readable, they want it to be elegant, they want it to be performant, they want it to be available, scalable, all of those things. I will say that aside from maintainability, you're usually wrong. You probably want all of these things for your product, but for your component, premature optimization is the root of all evil. but a senior engineer, a seasoned engineer with experience knows what premature is. So that's sort of the trick. Typically, what you want to do in an organization where you have lots of different teams and lots of different components that are interacting is that your optimizations are improving quality of delivery to other components in the architecture. So premature optimization is basically any effort you make to make it faster than is needed to satisfy their constraints. So I'm going to tell you how we were stupid so that you don't be stupid. So I'm really proud of our database. We have a database, a time series database. It's super fast, it's scalable, it's awesome, it's great. Okay, so what does fast mean? We have hundreds of millions of streams of data coming in, trillions of data points, and most queries that we answer, whether they're point in time or looking at a week or a month or a year of data, are answered in under 2 milliseconds, which is awesome. It's super fast. Great. I'm very proud of that. That's great. We do aim at 2 milliseconds. That was our original goal. Our original goal was that we should work to have all of our queries be sub 2 milliseconds. Okay, that's naive and self-defeating. There are a lot of queries, just by their very nature, that require more computation that can possibly be done in 2 milliseconds on any of the CPUs that we run on, even with map and reduce or anything like that. So why would I set this goal for queries that can't feasibly achieve that, right? I would have to make a faster processor to achieve that. That's not my job, right? So there will never be queries that there will be certain queries that never finish in this time. So we really needed to be most queries. We want most queries to finish sub 2 milliseconds. So we really need to classify that by workload. So we have a lot of different workloads. Again, I use this graph a lot, but a lot of times, I don't have the cumulative graph on this where all of these different colors are summed together, but it looks sort of like a normal beta distribution. And you'd look at it and be like, oh, I have maybe a mode or two and some long tail. But it's actually very distinct workloads if you look at the different colors. There's 3 different colors there. And each one of them has two humps. They're two accumulated beta distributions, which is really common in computing. But being able to see those 3 different workloads allows us to look at those and figure out which ones of these should be how fast, right? It allows us to explore those questions. So it's an overgeneralization to say that my product should be fast. We have metadata queries where we're trying to find things by their name and not by their data. We have point-in-time queries, like what's the last value for these 100,000 things. We have series queries, which are like, give me, of my Kubernetes clusters that have been run this year, which is like, I don't know, 15,000 things, give me the CPU rolling average over an hour and sum them up by workload and group them by this. Those queries are really useful, really important, but those are not 2 millisecond queries. Those are pretty heavy. So we want to actually make sure that we recognize heterogeneous workloads and establish corresponding heterogeneous expectations for those. I don't want fast stuff to be slower because I'm including slow stuff in my data set, and I don't ever want to have slow stuff be expected to be fast because that's just self-defeating. So it's also horribly unaligned. This is probably the most important part, is that 2 milliseconds was really a machismo, I think we can do it. Like, who the fuck cares? Like, users can't tell the difference between anything that's under about 200 milliseconds. Typically speaking, you load a graph, it takes 200 milliseconds or 50 milliseconds. There's a good chance that there's a network issue or a browser, JavaScript, a GC issue that introduces a hiccup of like 25 milliseconds in there, 30 milliseconds in there you don't control. 2 milliseconds is sort of like an idiotic objective if the systems that are consuming this can't even detect something that fast. So why would you promise that? You don't. I do. I was an idiot, right? So you don't want to do that. Humans actually only ever really get annoyed in our system when they're over about 2 seconds. So they want it to be faster, but they're always willing to wait 2 seconds. And when it goes over 2 seconds, that's when they ask, customer service, customer success, they're like, is the system slow? It seems a little slow. But they don't ask before that, right? So the user experience is still completely achieved anytime we have under 2 seconds. And then in our other workloads, so a lot of the queries that aren't consumed by humans are consumed by soft real-time systems, but a lot of those are measured in seconds or even minutes. Some system, like an auto-scaling system for Google GKE, right? You can do some sort of complicated mathematics on the telemetry coming out of the thing, and you're like, I don't have enough resources. I need to have more resources. That would be based on a lot of data. If I get my answer in about 15 seconds, that's fine. I'm going to spin up a new nodes, expand pods, whatever it is. If I do that within a minute, like I've already beaten the base Google product, right? So the expectations here are actually far longer than any of the engineers hoped that they would be so that they could valiantly tilt at that windmill. So we iterated and iterated and iterated, and we found that it was around 2.5 seconds where we wanted to set that. So just to put that in perspective, 2,500 milliseconds is a whole lot bigger than 2 milliseconds. You can imagine how much work it takes to try to make everything faster than 2 milliseconds versus some of our queries that impact users faster than 2,500 milliseconds. It's a radical departure for expectations. It makes it so much easier, so much cheaper for the engineering team to focus on that. And the most important part of all of that is that the engineering team is not focused on that. They're focused on other things, new requirements for the rest of the overall product. So this is where it gets caveated, okay? So when I say craftsmen shouldn't be focused on the performance and availability and the beauty and the elegance of the thing that they build, I'm not talking about these. If you're an author of libraries and frameworks that are consumed by hundreds or thousands or 100,000 people, you are at the point where that library and framework is the product. That is the thing. You need to consider all of these things. Very few people work on this exclusively, and we don't usually set SLOs for this stuff already. We make money from this. Every organization makes money from this. We download that off of GitHub or Maven or whatever, and then we jam it into everything you will ever write at your job, which is not typically consumed by a lot of different people in the organization. They come through your abstracted API. They come through your service boundary, right? So you've got this one thing, and it serves a group of people or a group of components. And the craftsmanship of that product, that is not a product, that component, is not as important as the overall craftsmanship of the aggregated product. And it's very easy to get distracted by that, because that's the world we control, and we're craftsmen, and we like to make it beautiful and make it great. But while you're busy trying to hit 2 milliseconds instead of 2,500 milliseconds, you're not adding critically important product features, the machine learning aspects to the database, all of the query engine optimizations that powers new things in the product, because you're busy trying to achieve a performance objective that just doesn't matter in the first place. So SLOs are about making promises, right? So if you set your objectives too high, or too tight, or unreasonably strong, one, you're going to miss them a lot. So it's always like, all I expect is everything to always be on time, which is like, how do you get your bonus for overachievement, right? You do more than everything on time, right? So if, for example, a train station, if the objective is that every train arrives on time, you can never exceed expectations. It's not possible, right? So you want to set these things a little bit lower so that they're achievable, but also you want to set them lower and around service boundaries that affect product, they affect revenue, they affect users, they piss people off, because when you don't hit them, it's a big deal. So you want to set these as low as possible so that you're almost always winning, and when you're not winning, we have a big group problem. So this is the progression, because a normal craftsman says, how beautiful can I make this? How fast can I make this? How reliable can I make this? Those are all interesting mental questions, like mental model questions. You should ask those. They improve your craft in general. You should not act on those. Those are horrible questions to act on. So how fast should we make this component? It's a much closer question. But really, it's how fast must we make this? How good must we make this? How available must this be? You get one meme, right? Objectives aligned with how good it must be is where you want to be. So if anybody says we could be faster, the answer is, great. It's not in my objective. It's not, my bonus isn't tied to it. I don't get paged at night when I'm not as fast as I thought I could be. I get paged at night, or I wake up and I don't get my bonus, or we hire more employees to fix these problems when we miss the objectives that we must deliver on. So parting thoughts. You should be doing SLOs, even if they're not called SLOs in your organization. But you should be setting objectives for availability, for performance. If you can set objectives around maintainability, a great objective around software components and products is onboarding time for new engineers. You should set objectives for that. If you hire a new engineer and it takes them 6 weeks to be able to write code versus 5 days or 2 days, that's a really critical measurement to how fast your organization can move and deliver new innovative value. Right, so those SLOs, they don't need to just be on the operations of the component. They can be on the maintenance of the component, the building of the component, the costs around that component, both OpEx and CapEx. There's not usually much CapEx on those. So you are, typically if you are adopting SLOs, you are literally investing time and money of engineers to meet an objective, so make sure it's worth meeting, right? So that 2 millisecond objective, if I hired 15 more engineers and they tilted at it and maybe got it, it wouldn't move the needle on the business. It wouldn't move the needle on the product, and users wouldn't care. So it's a really fun investment, and I'd feel great about it. I'd probably get a speaking slot and talk on stage about how awesome the team was, but that's not craftsmanship. That's not delivering the product we want to deliver to users. So another thing to think about is workload classification. So a lot of times people are much too broad with their objectives. You know, like onboarding a new employee into a code base, how fast should it be? Well, if you have one code base that's super complicated, that has all of your business and compliance logic in it, and it takes 4 weeks for someone to read the compliance specifications before they can even care about the code, so be it. Don't set the organization's objective, set the component's objective reasonably, right? If you have a fast-moving component like a web front end that you're constantly changing in order to meet market demand, like that's the one where you're like, hey, I'd love to have developers productive day one. The same goes for behavior, reliability. I gave a talk briefly before about abstraction boundaries. This is sort of the same thing around abstraction boundaries. If you take your components and you look at like one of them needing compliance versus one of them not needing compliance, you should really have different SLOs around those. Availability SLOs, reliability SLOs, things like that. Consider what is required. Don't think about what's reasonable or possible. Think about them. Don't think about them in this context. I mean, always welcome people to think about what data structure would be better, or how we could change the system in design to be more efficient or more effective, flow better, how could we have more or less components to enable the business to move faster or more safely. Those are great things, but when you're talking about your component, you really don't want to codify any of those dreams and hopes into things that you promise. And coming back to the SLO definitions, when you define these things, you end up waking up at night when they don't work. People's bonuses don't happen when they're not met. You end up hiring when you shouldn't if they're defined wrong. So you end up not hiring when you need to or hiring when you don't need to. So it's incredibly important that you articulate the questions very intentionally and very carefully. They don't need to be permanent. You can change these things over time, but be very specific in these things. So be careful and don't fuck up the math. So don't do your math wrong either. We had a customer once that had an objective of like 99.9% of their requests needed to be faster than 400 milliseconds. And they hired 3 people. We came in and found out they were calculating their 99% wrong. So they were actually achieving objectives, but because the math that they used had binned the data wrong in a histogram, they had error margin, and the answer that they got back would never change from like 450 or 500 down to the next bin until they like moved a considerable amount of the traffic faster. So if they had ever actually moved the needle that they were looking at, their requests would have been like sub 200 milliseconds, all of them. So they just had a great idea, and then the team that was collecting the data and the team that was doing the math and the team that was using the outputs of the math were disconnected on the importance of precision and accuracy in the process there. So make sure that the data that you use is good, you understand error margins on that data, and you do your math right, because you're going to be dropping mad stacks of cash into the problem otherwise. So I guess, is everybody ready to go do as little as possible? Thank you very much.
Thank you very much, Theo. We have time for a couple of Are you taking questions? He's taking questions. We have time for 2, maybe. Do we have any? We do? We do. Okay. From Anonymous, yet again, how to incorporate cascading SLO. Should you communicate you missed your SLO because someone down the line missed theirs?
How to incorporate cascading SLOs. So most of the time, we just don't see this done. People define their SLOs, and they can place blame. Because all violations of SLOs should absolutely be documented for any sort of component, right? So you should be able to say, hey, I'm a consumer of this thing. What were its service level? You know, what's its SLO? How close was it tracking to that? It's important to have a lot of transparency in that, because how you define your SLO may need to change over time, right? You have an SLO component that says, hey, I need to deliver most of my queries faster than 500 milliseconds, and I need to be up 99.5% of the time. Now you have a production critical service that comes in that needs you to be up more than that. There you need to come back and say, hey, we keep missing our SLO, and you keep hitting yours. I think your SLO's too low. I actually need more out of you, right? And without transparency, you don't see that. So you need sort of an open book in the organization, so you have feedback, but we don't tend to see them cascaded in mathematically, at least. You look at your own SLO, and then you kind of look at the components that you talk to and figure out how to give them active feedback.
Oh, yes, one more. Is it possible to define smart SLOs for a complex product with a lot of components?
So SLOs in general are usually around services. So they tend to work better around components of services. But at the end of the day, the more high level you get on a product, the more high level your SLOs get. They don't tend to be, you know, query rates or availability or performance. They tend to be like customer support call volume, tickets opened, things like that, where you have objectives around the product that end up being a lot more meta and a lot more, the proximity to revenue is much closer, right? So, because at the end of the day, like, if customers are happy, they're not leaving and they're paying you money, seems like you're hitting your objectives, right? So your objectives should really model the business, the more you get out to the product level.
Thanks, Theo. If you've got any question, there's a question there. Theo, you'll allow someone to come accost you down here and take it? Okay. So Theo's going to be here if you do have a question. Everybody give Theo an applause because he's done 2 talks and he's amazing.